Okay, so picture this, right? A nuclear reactor just humming away in the Gobi Desert, like this stark kind of beauty, you know?
Yeah.
And it's potentially powering over 100,000 homes.
Wow.
That image right there, that's China's experimental thorium reactor. And it just throws a spotlight on this whole really intriguing corner of nuclear energy, you know?
Yeah.
It does make you wonder if we're like seeing the very early stages of significant shift, maybe.
Oh, absolutely. I think it does. And, what's compelling is that this isn't something that just came out of nowhere.
Right.
Its idea of thorium has been around for a while. You have
Yeah.
India, of course, with its huge thorium reserves, and Japan, the UK, even the US at different points in time have all looked at it.
Yeah, it's kicked the tires a bit.
Yeah, so it's not an isolated thing.
Uh-huh.
You know what I mean? It reflects a persistent interest in what thorium could offer us.
Yeah, and for me, the big question that keeps popping up is what's the real draw? Like, why are we hearing this buzz about thorium? The word on the street is that it's way more abundant than uranium, and maybe it holds the key to a more sustainable nuclear future.
Yeah.
It's definitely got me hooked.
Well, and that's exactly the territory we're going to be diving into today.
Okay, awesome.
To really get a handle on this, we've been looking at this report from the IAEA.
Okay.
It's called Near-Term and Promising Long-Term Options for the Deployment of Thorium-Based Nuclear Energy. And it's not just some random opinions or whatever.
Right.
It's a 4-year research project that they did, a big one.
With tons of experts.
Yeah, involving international experts.
Oh, wow.
So it's giving us a very robust, science-backed perspective on all of this.
All right, well, that leads us to this really interesting quote I found from Kailash Agarwal. He's a nuclear fuel cycle facilities specialist at the AEA.
Oh, yeah.
And he describes thorium as a really attractive and viable option for generating power. And, he really emphasizes the role of this IAEA project in, bringing together global knowledge and expertise about this. It paints a very promising picture, right?
I think it does. I think,
Yeah.
Agarwal's viewpoint really underscores the potential that people see in thorium and this global effort to really investigate it.
Yeah.
And that's what we want to do with you today, a thorough deep dive into thorium. Look at the exciting prospects, but also be realistic about the challenges, because there are some.
For sure. For sure. Okay, so we keep saying thorium, but what is this stuff beyond being nuclear fuel? What is it like in its basic form?
So basically, it's a naturally occurring metal.
Okay.
It's silvery looking, and it's slightly radioactive. You'll find it concentrated in certain types of rocks, igneous rocks, and these heavy mineral sands.
And I came across this fact that I just thought was so cool.
Oh, yeah.
It's named after Thor,
Oh, of course.
the Norse god of thunder.
Yeah.
I mean, that's a much cooler origin story than uranium, don't you think?
Way cool. It's like out of a Marvel movie, right?
Right. It's like, wow, that's awesome.
It adds a little mythological heft to the periodic table.
Right. But, okay, so beyond the cool name, what else is there?
So beyond the name, its abundance is a key thing here.
Okay.
Thorium is estimated to be like 3 to 4 times more common in the Earth crust than uranium.
Really?
Yeah. So that kind of begs the question, if it's so readily available, why haven't we been using it all along?
Yeah, that's a good question.
Why is it not a primary energy source already?
Right.
So that's the kind of question that's hanging out there.
Yeah, it is. And I think part of that answer lies in this, really critical difference between thorium-232,
Right.
which is the only naturally occurring isotope of thorium, and that uranium isotope uranium-235.
Yeah, exactly.
Do use in reactors. Could you maybe walk us through that?
Sure. Yeah. So uranium-235 is what we call fissile,
Okay.
meaning its nucleus can easily undergo fission, so it splits apart
Okay.
when it absorbs a neutron, and that releases a ton of energy.
Right.
And that's what allows it to sustain this chain reaction, which makes it usable as fuel.
Okay.
Thorium-232, on the other hand, is fertile, not fissile.
Okay, so what does that mean?
So it can't sustain a chain reaction directly on its own.
Okay.
It has to be transformed into fissile material first.
All right, so it needs a little help.
It needs a little help.
Okay.
Think of it like kindling to start a fire.
Yeah.
Thorium is the fuel, but it needs that initial spark.
I got it. Okay, so it's not directly usable as is.
Not quite.
How does that conversion happen?
So when thorium-232 absorbs a neutron,
Okay.
it could be from an initial reaction or some other neutron source.
Right.
It starts changing.
Okay.
It becomes thorium-233,
Mm-hmm.
which is unstable, and decays into protactinium-233.
Okay.
And then that decays again into uranium-233.
Okay.
And that is fissile.
Oh.
So through that process, you're essentially breeding thorium-232 into fissile uranium-233.
Okay, so that's that key difference that we need to understand.
Exactly.
Okay, so now we have a grasp of what thorium is, how it can become a usable fuel. Let's get to the fun part. What are the advantages?
All right, let's talk about the upsides.
Yeah, what can thorium offer to you and me?
So the big one that everyone talks about is abundance.
Right.
Like we said before, thorium is much more concentrated in the Earth's upper crust than uranium.
Yeah.
Like 10.5 parts per million versus about 3 parts per million.
Okay, so that's like 3 times as much.
Yeah, about 3 times as much. And some estimates suggest that global thorium reserves could be way bigger than uranium reserves.
Wow, that's a huge difference.
It's a potentially massive difference.
Does that mean that we'd have a much more secure and long-lasting fuel supply?
That's exactly what it means. And that's where the idea of breeding that we talked about becomes super important.
Right.
Because certain reactor designs, like molten salt reactors and some types of water-cooled reactors,
Okay.
they can actually produce more fissile uranium-233 from thorium than they consume.
Wow.
It's like creating fuel as you use it.
That sounds almost too good to be true.
I know it's very attractive in terms of energy security and reducing our reliance on limited resources.
Right.
And this guy, Kailash Agarwal from the IAEA, he really emphasizes this point.
Yeah.
He says that thorium's abundance and its breeding potential make it a strong contender for a long-term energy solution.
Wow, that's a big statement.
Yeah, it is.
Okay, so beyond just having more fuel, what about the environmental impact?
Yeah, that's a big one.
That's a major concern with nuclear power.
You're absolutely right.
So how does thorium stack up?
So this is another area where thorium potentially has an advantage.
Okay.
Like conventional nuclear power, thorium reactors don't produce greenhouse gas emissions while they're operating,
Right.
which is obviously huge when we're talking about climate change.
That's a big plus.
Yeah, it is.
But then there's the whole nuclear waste issue.
Yeah, of course. That's always a part of the conversation.
So where does thorium fit in there?
Well, thorium cycles actually offer a bit of an advantage here.
Okay.
While they do produce radioactive waste that you have to manage carefully,
Right.
the waste itself is considered less problematic in the long run than the waste from uranium reactors.
Okay. Why is that?
Because thorium cycles, they produce a smaller amount of these transuranic elements,
Okay.
like plutonium and americium, which have really, really long radioactive decay periods.
Like how long?
We're talking tens of thousands of years or even more.
Wow, that's a long time.
Yeah, it is.
So the waste from thorium is better?
Well, the thorium waste has a higher percentage of these fission products with shorter half-lives.
Okay.
So the radioactivity decays to safer levels much quicker.
Okay, so how long are we talking?
Maybe a few hundred to 1,000 years.
Okay, so still a long time, but way less than tens of thousands.
Exactly. It's a significant difference.
Right. Okay, so it seems like thorium has a lot going for it.
Yeah, it seems that way.
Abundant fuel potential for long-term sustainability, no greenhouse gas emissions during operation, less long-lived waste.
All good things.
It's like checking off all the boxes, but we know there are always challenges.
Always.
What are the things that make deploying thorium power so tricky?
Well, one of the big ones is economics. Even though there's a lot of thorium out there, extracting it in a commercially viable way is actually more expensive than extracting uranium right now.
Really?
Yeah.
So it's just sitting there. Why is it so hard to get out?
It comes down to how it's found and what the market wants, basically.
Okay.
So this guy, Mark Mihalaski, who's an IAEA uranium resources specialist,
Okay.
he points out that a major source of thorium is this mineral called monazite, which also has a lot of rare earth elements in it.
Oh, I see.
And right now, those rare earth elements are in high demand.
Yeah.
They're super valuable for all kinds of technology.
Everything.
So basically, we're mining the monazite for those.
For the rare earths.
And thorium is just kind of like a byproduct.
Oh, so we're digging it up anyway.
Yeah, pretty much. And when thorium isn't the main target, the methods they use to extract it can be more complicated and costly than what we use for uranium.
Which makes sense.
Yeah, so as Mihalaski explains, the cost effectiveness of thorium extraction just isn't there yet compared to uranium.
Not while we're focused on those rare earths.
Exactly.
But could that change? I mean, if you started really using thorium for power, would that make a difference?
Yeah, that's definitely a possibility.
Okay.
If demand for thorium shot up, we might see more efficient extraction technologies developed specifically for it.
That makes sense.
And the cost could come down.
Okay, so the market has to catch up a bit.
The market has to catch up.
What about the actual technical side? Are there any big engineering hurdles that we need to overcome?
Oh, yeah, for sure. Anselika Kaprskaya, who's the IAEA's technical lead on fuel engineering.
Okay.
She says there are substantial costs and time involved in the research and development to bring thorium power to the mainstream.
Right.
We just don't have as much experience with thorium fuel cycles as we do with uranium.
Right. We've been working with uranium a lot longer.
Decades longer.
Yeah.
So we're playing a bit of catch-up.
Right. So we're starting from scratch, almost.
Kind of. And Kaperskaya also points out another challenge. Thorium is fertile, not fissile. Remember?
Right. It needs that little kick.
Exactly. It needs a source of neutrons from a fissile material like enriched uranium or plutonium to get the reaction going.
Okay.
And that adds complexity to the whole reactor design and fuel fabrication and operation.
So it's not as simple as just swapping out the fuel.
No, not at all.
Okay, so extracting the fuel is more involved.
Right.
And the reactor technology is more complex.
It's a whole new ballgame.
It feels like a bit of a chicken and egg problem.
I say that.
Okay, so we've got these economic and technical challenges, but there's still a lot of interest, like we see with China's experimental reactor.
Absolutely.
So what's the overall feeling about thorium's long-term potential?
Well, Clement Hill, who is a section head at the IAEA, he says that we're all looking for sustainable and reliable energy technologies to meet global demand and address climate change.
Right.
And he thinks thorium could be one of those technologies.
So even with the challenges, people are still hopeful.
Yeah, the potential is there.
That's encouraging.
It is. And Hill also says that the IAEA is going to keep researching and collaborating on this to provide solid information for anyone who's interested.
That's great.
Yeah, the exploration of thorium is definitely ongoing.
Okay, so to sum things up for everyone listening,
right,
we've taken a deep dive into this fascinating world of thorium.
We have.
We've seen its potential for clean and sustainable energy, maybe even breeding its own fuel.
That's the dream.
But we've also talked about the economic realities and the technical hurdles.
Both sides of the coin.
And it's that balance between potential and challenges that makes projects like China's experimental reactor so important.
Absolutely. They're taking concrete steps to figure this all out.
And that leads me to a final thought for you all listening.
Okay.
We've discussed the benefits and the obstacles, so what do you think will be the deciding factor for thorium?
Yeah.
Will it be a new technology, a shift in the market, or something else entirely?
It's a tough question.
It's a complex equation for sure. And with that, I think we'll leave you to ponder that one.